to start organic chemistry. First, we are going to concentrate on lessons reactive intermediates. What is meant by intermediate? When the reaction proceeds, the reactant will tend to give products. The transition state which is unstable is known as intermediate. Intermediates are generally unstable. Among that intermediate, there may be a stable form. What are they? We need to discuss here. First, intermediate is carbocation. Based on this carbocation, we need to know more, and it is very important for PG and all other entrance exams. It is useful about carbocation. We know generally carbon has 4 valency, that is tetravalent, and it 4 bond we take into account, that is known as sp3 hybridization. Okay, sp3, and you know sp3 means tetrahedral. So whether there is 2 bond means linear, 3 means trigonal planar, 4 means tetrahedral, 5 means trigonal bipyramidal, 6 means octahedral. That is according to VSEPR. And here there is CX. We take here H. Here one X. X is a more electronegative atom like chlorine or bromine. So what will happen? All we know, X will take this bond and go out as X minus, and will become C will become cation. So the structure become like this. Tetrahedral changes into trigonal planar. How many bonds? Just count 1, 2, 3. If 3, that is trigonal planar. So trigonal planar. How many bond is there? 3 bonds are there. So 3 bonds means 1 bond will give 2 electrons. 3 bond will give 6 electrons. Here there is 4 bonds, so 8 electrons. 8 electron we need to say at octet. Here there is 6 electrons, so we say that as sextet. Octet only the correct configuration for a molecule. Here this is 6 electron and this is sextet, so this is electron deficient. Carbocation is considered as electron deficient since it does not follow octet rule. So we know here 109.5 degree bond angle for a tetrahedral compound. Here this is 120 degree for trigonal planar. 8 sextet electrons, trivalent because 3 bonds, and sp2 for this hybridization. Since it is 3, so sp2 for 2 sp, sp3, sp3d and sp3d2 since it contains. And now we are going to discuss about carbocation, carbenium, carbonium. What are they? Is 3 are similar or different? And very well we know about carbenium or carbocation. Mostly these 3 also same only. Mostly carbenium, carbocation, carbonium are same. But we need to know the difference between exactly among this. Why? Because this is useful for our higher studies, and we need to know to differentiate this among. Carbenium or carbocation will contain CH3 plus, and carbenium ion follow the same trend of carbon ion in every cases. But this carbonium will not be similar to carbocation in all cases. There will be exceptional for this carbonium ion. So we are classifying carbenium under the carbocation and giving the same structure CH3 plus. Hydrogen, CH3 plus. So follows the same trend of carbocation. Other name for carbocation is carbenium ion. And what is carbonium ion? It is CH5 plus. Here hydrogen, and these 2 hydrogen are unstable hydrogen. This is known as transition state. These hydrogen will exchange each other and will dissociate quickly. This is just an imaginary state. Now say how many bonds? 1, 2, 3, 4, 5. Pentavalent. This is pentavalent. But we need to counting electron. We need to be careful. Here 2 electron, here 2 electron, here 2 electron, 6 electron. But this bond, this is only pentavalent, but this hydrogen 1 electron, this hydrogen 1 electron. So totally this contain 2 electron. So 8 electron octet. While counting valency, this is pentavalent because of bonds. But counting electrons, one need to be careful because I dotted here. Here there is 8 electron only, since these hydrogen contain each as 1 electron. According to VSEPR, we will expect trigonal bipyramidal because 5 bond. 1, 2, 3, 4, 5. We will expect trigonal bipyramidal. Nothing wrong. Many book they given us trigonal bipyramidal, but they are asking reality structure means trigonal planar. Both also according to me correct. What option they are given, you need to select according to this basis. and hybridization sp2 only, because you know carbon does not contain d orbital. So these two hydrogens are unstable, so these two hydrogen will take part, and only we have 3 hydrogen only that correspond to sp2. These two hydrogen are imaginary, don't consider this. We need this 3 hydrogen only with carbon. So only 3 hydrogen, 3 bond correspond to trigonal planar, and it contain sp2 hybridization. Okay, expectation is trigonal bipyramidal, no wrong about shape. Shape may be trigonal bipyramidal or trigonal planar, no problem about shape or geometry, but one need to take care in your hybridization, that is must be sp2. Now we are moving on to stability of carbocation. Tertiary is greater than secondary is greater than methyl. One well know about tertiary. Tertiary means carbon will not contain hydrogen. All will attach to other groups. Secondary means one hydrogen, and other 3 will be other groups. Primary means there will be 2 hydrogen. Methyl means you know well CH3 plus only methyl cation. Stability of carbocation, tertiary is greater than secondary is greater than primary is greater than methyl. This is the stability of carbocation. We need to memorize this like a table for the carbocation stability, and I will discuss this later with more examples. We will discuss this is more important for your jam, CSIR, NEET, and more on. Now I give you according to what I given before. Generally you need to compare the stability and say in comment section. CH3 plus CH3 CH2 plus CH3 CH plus CH3 CH3 thrice C plus, which is more stable? Give the order of this. Take this as A, take this as B, take this as C, take this as D. Okay, according to this rule what will be the answer? Don't go with explanation, just memorize this rule and apply here. And I am given neopentyl carbocation, isopropyl carbocation, tertiary butyl carbocation. Among these 3, which is more stable? Give the order A, B, C for 1 and 2. Try this. We will post a later video about the stability, and more examples will be given on that video. Thank you. Hope that you are clear. Thank you.